Fall protection can be one of the most complicated and lengthy subjects when it comes to worker safety. And there's reason for it. That's because over the years, we've been able to gather data to provide better information, standards, and guidance on protecting workers from fall-related injuries or death. So while yes, it can be a complex subject, this training is carefully designed as a fact-based crash course that covers several different fall protection topics in an easy-to-learn and digestible manner. However, this training alone isn't a substitute for on-the-job training by a competent person. So while this class is excellent, it needs to serve as your baseline of knowledge. You still need to understand the specific hazards of your work and how to protect yourself from injury. So in other words, what you learn here today, you need to apply and practice these skills every day. So with all that said, if you're in this training, you're somehow affected by fall hazards. Whether you're climbing a step stool in the William T. Young Library, working near the edge of the roof on Patterson Tower, or just changing light bulbs in the Jacobs Science Center at the University of Kentucky, we take fall protection seriously. That's one of the many reasons we have designed a robust program that captures some of the hazards that you might be exposed to and what we're going to do to protect you. Our program provides clear and concise guidance, including requirements, roles and responsibilities, training requirements, design standards, and more. So before we dive too deep into fall protection, let's quickly look at the course outline for today's training. Chapter 1, Introduction to Fall Hazards. Chapter 2, Defining Falls and Hazards. Chapter 3, Fall Hazard Awareness. Chapter 4, Hierarchy of Fall Protection. Chapter 5, Fall Protection Systems. Chapter 6, Ladders, Scaffolding, and Aerial Lifts. Chapter 7, Fall Rescue and Emergency Response. Chapter 8, Training and Compliance. Chapter 9, Key Points and Final Thoughts. Just know that you can pause this training at any time and pick right back up where you left off. Chapter 1, Introduction to Fall Hazards. At the University of Kentucky, all elevated work is subject to the policies outlined in our fall protection program. This program follows OSHA's guidelines and is designed to eliminate or control fall hazards before work begins. That said, we're not the only place to have strict guidelines. Yet falls remain the leading cause of death in industry, accounting for over 1/3 of all fatalities annually. That said, falls consistently top the list of OSHA's Fatal 4 over incidents like struck by, caught in between, and even electrocutions. The highest fatality rate is among those working in sectors such as construction, warehousing, telecommunications, IT, and maintenance. So if you're in this training, there's a good chance that your job duties have fallen into one or more of these high-risk categories. And as much as we wish it wasn't the case, the reality is that fatalities can occur. According to the BLS, as of 2023, falls accounted for 421 of the 1,075 deaths in construction. That's 40% of all deaths that occurred from fall-related incidents, which is the highest we've seen since 2011. So out of those 421 deaths, 260 or 64.4% were between 6 and 30 feet. 67 of these falls were from a height of more than 30 feet. It's also worth noting that portable ladders and stairs were the primary source of 109 fall-related fatalities in construction. I say all that to ask this question: why are we seeing a rise in fatalities related to falls? Well, the answers to that question are complicated. The spike in fall-related fatalities is generally a combination of increased exposure to fall hazards, insufficient use of protective measures, systematic issues within smaller companies, and vulnerable worker populations. So now you might be asking, well, what can we do? How can we ensure that none of us are a part of this statistic? Tackling this challenge will not be easy. It will require effort from all parties involved. This means we need enhanced training, stricter enforcement of safety regulations, and a substantial commitment to fostering a safety culture across all industry levels. But before we dig deeper into fall hazards, if we're going to fix this problem, we need to define what it is. Chapter 2, Falls and Hazards. A fall hazard can be generalized as any situation in which a worker is at risk of falling. That said, to fully understand the dangers of a fall hazard, let's take a look. According to OSHA, a fall is defined as a sudden, unattended descent of an individual's body to a lower level. This means that it ranges from falling on the same level, like falling on the floor, to falling from a high level, like a skyscraper. Regarding the term hazard, OSHA defines it as a potential source of harm, damage, or adverse health effects on something or someone under certain conditions at work. That means we can interpret a fall hazard as any condition that puts an employee at risk of falling from a higher level to a lower level, or even the same level. This includes unprotected edges, floor openings, and other conditions on working or walking surfaces. Applying the criteria and definitions of a fall hazard, we see that there can be a massive range of various heights and working surfaces. Whether you're putting books away on a step stool or working on replacing shingles on a roof, these would both be considered fall hazards. That said, while all falls can be deadly, our focus needs to be on high-risk events that, if a fall was to happen, have a much higher chance to leading to severe injury or even death. So how do we determine which falls have a higher risk? To understand this, we need to reference the the University of Kentucky's Fall Protection Program. In this program, you'll find that any task performed more than 4 feet above a lower level must be reviewed by a competent person or someone from the University of Kentucky's Occupational Health and Safety Department. This ensures that proper fall protection systems are in place before work begins. Even so, hazard identification and assessments are key components of our approach to safe elevated work. Along with that 4-foot requirement, hazard identification and hazard assessments are key components of our approach to safe elevated work. So I get it. On the surface, 4 feet doesn't sound like that much, as 4 feet is about the height of an average 7 or 8-year-old child. But the data has shown a fall from 4 feet or higher have a much higher chance of causing severe head trauma, broken bones, internal injuries, and unfortunately, death. So now if we extrapolate this, the higher you're working, the more significant your injury could be. Chapter 3, Fall Hazard Awareness. So far, we've discussed a rise in fall-related deaths, what a fall hazard is, and why we must provide safeguards at heights of 4 feet or higher. Now let's begin to weave in some examples of fall hazards that you need to be aware of when performing any task on campus. Number 1, unprotected edges. These are any elevated walking or working surfaces that lack guardrails or barriers. Think of a roof perimeter, open floors in new construction, mezzanines, balconies, or loading docks. These areas are hazardous because the fall risk is often right at your feet and easy to overlook. Number 2, floor holes and openings. Skylights are a big one here. They may look solid, but they're often made of brittle materials like plastic or fiberglass and won't support a person's weight. Other examples can be an open elevator shaft, stairwells, or even temporary holes cut for ductwork or piping. If these aren't properly covered or guarded correctly, they become serious fall hazards. Number 3, ladders. Ladders are a tool that a wide range of employees use almost every day. And depending on that frequency, this can lead to worker complacency. So just because you've never had an incident doesn't mean that you're immune from fall hazards. Improper setup, unstable footing, overreaching, or simply climbing with your hands full can quickly lead to a fall. And number 4, rooftop work. Whether installing HVAC systems, inspecting vents, or laying shingles, rooftop work poses one of the highest risks, especially on sloped or flat roofs without parapets or guardrails. This is even more so when the weather adds slipperiness or reduces visibility. So while those 4 might be the most common, don't forget that hazards aren't always obvious. That's why hazard recognition is everybody's responsibility. So with that said, before you begin work, ask yourself this series of questions. Are there any edges, holes, or drop-offs nearby? Will I be using a ladder, a scaffold, or a lift? Do I need to be on a roof? Am I going to be near a ledge or working near an opening? Is there a chance that I could fall from this height? If you can honestly answer yes to any of those questions, we must ensure that you have appropriate protections before the work begins. Finding hazards in your work area isn't always easy, especially if you've done the work for a considerable amount of time. But making sure that you're asking yourself a few questions prior to the work beginning can be a powerful tool in keeping you safe. So like we said earlier, hazards don't announce themselves or even make themselves known. That means all of us must actively look for them. According to OSHA, most fatal falls happen between 6 and 30 feet. That means many of these fatal falls that we're seeing aren't from tall buildings like Patterson, but from ladders, scaffolds, and small buildings. In other words, this is most likely from the places where most of us work daily, and those hazards won't necessarily present as a fall hazard at first. So be on the lookout for a few common, less apparent examples of fall hazards. Working from trucks, trailer beds, or loading docks. Most of the time, these will be built just under that 4-foot fall protection requirement. Another less apparent example of a fall hazard could be climbing up storage racks or shelving, or even using a man basket without proper tie-offs. So as much as we want to eliminate all fall hazards on our campus, that's just not the reality. We'll always have some work that needs to be done on top of one of our buildings, or something as mundane as changing the lights. That's why awareness is critical, not just for known fall hazards, but for the lesser known ones. Remember, you can't protect yourself from something that you don't perceive as a threat. So now that we're aware of some of the fall hazards that we're exposed to, how are we going to address these? Chapter 4, the hierarchy of fall protection. To effectively protect all employees, it's not as simple as just putting on a harness and tying off to something. It's about choosing the proper protection strategy for the job, and that begins understanding the hierarchy of fall protection. This hierarchy is a step-by-step approach to controlling hazards. It's endorsed by OSHA, ANSI, and other safety leaders in the community. And the principle behind it is easy to remember. We always want to start with the most effective strategy and move down the list when safer options aren't feasible. So let's quickly break down the 5 levels of this hierarchy. Number 1, elimination. This is the gold standard. If you can remove the hazard, do it. For example, instead of designing an AC unit on top of a building, the AC unit is relocated and designed on the ground level, thus eliminating elimination. No height, no hazard. Number 2 is passive fall protection. These are built-in physical systems that protect workers without requiring their actions. Guardrails, safety nets, and floor hole covers fall into this category. These systems are highly effective and reduce reliance on individual behavior. Number 3 is fall restraint. Restraint systems prevent a worker from reaching a fall hazard. For example, a fixed length lanyard that's attached to a secure anchor can physically stop the worker from moving close enough to fall. You can most likely find these sort of systems being used on flat rooftops or elevated platforms. Number 4 is fall arrest. This system is used when the risk of falling cannot be eliminated or prevented. Fall arrest systems don't stop the fall from happening. They stop it once it begins. This includes a personal fall arrest system with a harness, lanyard, and anchor points. These systems must be used and maintained correctly to work as intended. And finally, number 5, administrative controls. These procedures and policies influence behavior, such as warning lines, signage, work rules, and training. While not as effective as physical protection, they can help reduce risk exposure when used in conjunction with other methods. So the important takeaway here is that these methods are unequal in effectiveness. That's why the hierarchy exists in the first place. We use it to help guide us to the safest possible solution and not just default to PPE or training as the main solution. At the University of Kentucky, we believe in this methodology. That's why we follow OSHA's recommended hierarchy of fall protection and always emphasize eliminating the hazard first. If elimination isn't possible, our policy then directs departments to implement passive systems like guardrails, followed by restraint and arrest systems. And finally, we use administrative controls to reinforce these measures through training and documentation. So now that we have an understanding of the hierarchy of controls, let's explore some of these systems and how they protect us. Chapter 5, Fall Protection Systems. So now that we have an understanding of what the hierarchy of controls are, let's now explore the systems that protect us when we're working at heights. Essentially, these are the physical and personal tools designed to either prevent falls or reduce the severity of injury if one was to occur. So let's start with guardrails. Guardrails are one of the most common and effective passive fall protection methods. OSHA requires that guardrails be 42 inches high, plus or minus 3 inches. They must include midrails and toe boards, prevent tools or debris from falling and striking workers below, and any openings that are in the guardrail must not allow a 19-inch object to pass through. Next, we have our personal fall arrest system. This system is your last line of defense and should only be used when there's no other option feasible. That said, a personal fall arrest system has 3 main components. The first is your full body harness. This should be worn snugly and distribute fall forces across the thighs, chest, shoulders, and pelvis. The second is your lanyard. These can either be shock absorbing or self-retracting. Shock absorbers limit the arresting force to 1,800 pounds. Self-retracting lifelines, or SRLs, activate quickly and reduce the fall distance. And the third is our anchorage point. This must support 5,000 pounds per attached worker or be designed with a 2-to-1 safety factor by a qualified person. Just having the harness on but not wearing it correctly can still lead to a catastrophic injury if a fall was to occur. So let's make sure that you're fitting your harness appropriately by following the next couple of steps. Straps should be tight but not restrict your movement. The D-ring should sit between the shoulder blades. Leg straps should be secure and not twisted, as an improper fit can cause serious injury in a fall. And most importantly, when it comes to your harness, remember, it's either 100% on or 100% off. And also, don't forget to do your daily pre-use inspection on any harness that you're going to wear. You want to be looking for any sort of fraying, buckles that don't latch, damaged stitching, and signs of wear. In addition to your pre-use inspection, OSHA requires a periodic documented inspection by a qualified person to any of your personal fall arrest systems. So it's important to note here, just because you're wearing a harness and you're attached to something doesn't mean that you're going to be protected if a fall was to occur. That's why it's so important to not only wear your harness correctly, but you want to make sure that that harness is tied off to a proper anchorage point. So briefly, let's talk examples. A good anchorage point could be a structural steel beam or even a manufacturer installed anchor that's rated for the appropriate fall arrest. A bad anchor or a bad place to tie off would be something like a conduit pipe, a lighting fixture, or any railing that's not been tested for fall loads. So remember, these systems are only effective if they're used correctly and consistently. Failure to miss just one of these steps when setting up your fall arrest system could still lead to catastrophic results for you and your coworkers. So if we remember back on our hierarchy of controls, ideally, we want to remove any of the fall hazards or prevent the fall from occurring in the first place. Wearing a harness and being tied off is our last line of defense against fall hazards. Ideally, we want to eliminate or prevent the fall from occurring in the first place. It's also worth noting that at the University of Kentucky, all personnel that are working at heights are required to complete fall protection and ladder safety awareness training. These will typically include hands-on instruction protection in using a personal fall arrest system, inspecting your harnesses, and identifying proper anchorage points. All of these standards are reinforced in both classroom training and your department-specific plans. Chapter 6, ladders, scaffolding, and aerial lifts. Ladders, scaffolding, and aerial lifts are not only some of the most common tools on a job site, but they can also be some of the most commonly misused tools. So whether it's complacency, shortcuts, lack of training, or something else, these sort of devices can turn a routine job into a catastrophic, life-changing event. So let's dive into some of these tools and how you can be safe while using or around these pieces of equipment. Let's start with ladders. OSHA's construction standard for ladders falls under 29 CFR 1926 subpart X, and the rules are specific for good reason. Ladders are involved in hundreds of injuries and dozens of fatalities each year. So here are some of the key requirements and best practices when it comes to ladder safety. Angle it correctly. Always follow the 4-to-1 ratio. For every 4 feet of vertical height, place the base 1 foot away from the wall or surface it's resting against. Inspect before use. Check for cracks, missing rungs, loose feet, or bent rails. If it's damaged at all, tag it out and don't use it. Always maintain 3 points of contact while climbing. Remember, this needs to be 2 hands and a foot or 2 feet and a hand. Don't carry tools in your hands. Use a tool belt or a rope hoist, and never stand on the top rung or the top cap of a ladder. And also remember, while sometimes inconvenient, we never want to place our ladders on unstable or uneven ground. It also goes without saying, we never want to place our ladders on anything that's going to give us additional height. Using a ladder that could be damaged on uneven ground or even in an incorrect manner is easily a recipe for disaster. So make sure that you're using your ladder, regardless of height, the way that it's properly intended. Next, let's talk about scaffolding. This is regulated by 29 CFR 1926 subpart L. Falls from improperly constructed or used scaffolds are among the leading cause of death in construction safety. So here are some of the key safety measures that we want to look out for. The first is guardrails. Guardrails are required when scaffolds are more than 10 feet above a lower level. The platform must be fully decked with no significant gaps or missing planks. Workers must have a safe way to get up and down ladders, stairs, or some sort of built-in access point. If guardrails aren't in place, workers must use a personal fall arrest system. And of course, daily inspections. A competent person must inspect scaffolds each day and after any event that could affect structural integrity, like for example, heavy weather, or if any modifications have been made. It's also important to remember your load ratings. Scaffolds must be designed to withstand their own weight, plus 4 times the maximum intended load. Any sort of overloading to scaffolds, whether it be people, equipment, or materials, can lead to a collapse. And finally, let's spend some time on aerial lifts. When we talk about aerial lifts, we include both scissor lift and boom lifts into this. These fall under 29 CFR 1926.453. Scissor lifts are often considered safer because they move vertically, and OSHA allows the guardrails to serve as fall protection. But that doesn't mean they're risk-free. They can still tip over if misused. Boom lifts, on the other hand, require a personal fall arrest system. Workers must wear a full-body harness with a lanyard attached to the designed anchor point inside of the basket. This is because boom lifts can experience sudden jolts or catapult effects when hitting an obstacle or a sudden stop occurs. Never exit a lift at height unless specifically authorized and protected by a fall restraint or a fall restraint arrest system. Make sure to secure the lift by locking the wheels or use outriggers if available. Don't use the lift on uneven or unstable surfaces. Watch for overhead hazards like power lines, beams, or low ceilings. And finally, training. Training is mandatory before using any type of aerial lift, regardless of experience level. So I think it's worth noting some of the highest violations that OSHA cites every single year. The first is using ladders incorrectly. This could be employees standing on the top step, leaning them against unstable surfaces, or even using a damaged ladder. The second is scaffold platforms without guardrails or full planking. The third is workers, while using a boom lift, aren't wearing a harness, or they're wearing the harness but it's not connected to an anchor point. And the fourth is moving a lift with the worker raised in the air, which is strictly prohibited unless the manufacturer allows it and the surface is flat. So some of the tools that we may use every day, like aerial lifts and ladders, may seem simple, but all of these tools continue to kill workers every single year. So just because you're familiar doesn't make it inherently safe. Make sure to follow the procedures every time without exception. Chapter 7, Fall Rescue and Emergency Response. It goes without saying, preventing falls is always going to be our first priority, but sometimes even with the best systems in place, accidents still can occur. That's why rescue and emergency planning is a critical component of what our program is all about. So for all intents and purposes, if If an accident was to occur, immediately call 911. That said, just telling you to call 911 isn't enough. OSHA requires that the University of Kentucky develops a site-specific fall rescue plan that details how to promptly and safely retrieve a worker that has fallen and is suspended in a harness. These plans designate building emergency coordinators, outline communication protocols, and provide steps for immediate rescue and emergency medical assistance. So in terms of a fall incident, why is a quick rescue so important? When a fall is arrested by a personal fall arrest system, the worker may be left dangling in midair. This isn't just uncomfortable, it's dangerous. A condition known as suspension trauma can begin to set in. Blood begins to pool in the legs due to inactivity and restricted circulation from the harness, depriving the brain and vital organs of oxygen. The result can be nausea, fainting, organ damage, and even death if the worker is left hanging too long. Ideally, we want to initiate the rescue response within 4 to 6 minutes or less. So let's touch on what our rescue plan should include. A proper rescue plan should look something like this. It should identify potential fall scenarios that are specific to the job site. They should designate trained rescue personnel, whether they're coworkers, supervisors, or dedicated first responders. They should detail any of the available equipment, whether it's ladders, aerial lifts, rope descent, rescue systems, etc. They should specify anchor points and access routes. They should include communication protocols like radios, whistles, and alarms. And they should incorporate drills and practice sessions. So just in case an incident occurs, everybody is trained and understand what their role is. So let's tie all this together and let's talk about the University of Kentucky's fall rescue planning. At the University of Kentucky, the Occupational Health and Safety Department requires that all departments develop and implement fall rescue procedures that meet both OSHA 29 CFR and the University of Kentucky's internal safety standards. Within this plan, some of the topics that we require are a pre-job planning for tasks at height, ensuring fall arrest rescue equipment is on site and accessible before elevated work begins, and rescue drills and training, particularly in labs, maintenance operations, and facility services. UK also trains its personnel in ladder safety and fall protection, which includes fall rescue awareness. For any other ladder safety or fall protection resource, including specific building emergency action plan guidelines, you can find these templates at ohs.uky.edu. Chapter 8, Training and Compliance. Training is the cornerstone of an effective fall protection program. Without it, even the best procedures and equipment can fail. So at the University of Kentucky, ensuring that all personnel are adequately trained and compliant with safety standards is our top priority. Even so, the Occupational Health and Safety Department at the University of Kentucky requires that all employees exposed to fall hazards complete a certified fall protection training course. This includes instruction on hazard recognition, proper use of fall protection equipment, inspection routines, and rescue procedures. All employee training records must be maintained to ensure compliance with OSHA 29 CFR 1926.503. So let's spend some time talking about what OSHA requires in terms of training and compliance. Under OSHA Standard 29 CFR 1926.503, employers are mandated to provide a training program for each employee who might be exposed to fall hazards. This program must enable employees to recognize the hazards of falling and train them in the procedures to follow and minimize these hazards. Some key elements include understanding fall hazards and identifying potential fall risks in the workplace, proper use and training on any of our fall protection systems. This includes but not limited to personal fall arrest systems, guardrails, safety nets, and other protective measures. Educating employees on how to inspect equipment before use and report any defects. And lastly, emergency procedures give us the instructions on the steps to take in the event of a fall, including rescue operations. So even though you may have been trained once before, it's important to understand why retraining is necessary. Retraining is required when there are any changes in the workplace or changes to the fall protection systems that render previous training obsolete, or due to an employee's actions, they may have not retained the necessary skills and requirements. So let's tie this together and let's review our university's fall protection program. The University of Kentucky has developed a comprehensive fall protection program overseen by the Occupational Health and Safety Department. The program aligns with the OSHA and ANSI standards and is designed to eliminate fall hazards and protect workers performing tasks on elevated surfaces. Some Some of the key components of this program include applicability. This program applies to all UK employees and contractors engaged in work at elevations. Responsibilities are broken down into 3 categories. Employees must be familiar with the fall protection program and collaborate with the competent persons to ensure safe work practices. Supervisors are responsible for eliminating fall hazards and ensuring protective measures are implemented. And the UK Occupational Health and Safety Department is to provide oversight, training, and resources to support the program's implementation. As we've talked about previously, within our fall protection program, we're required to detail our fall rescue and emergency response procedures. This means that in addition to fall protection, our program emphasizes the importance of fall rescue and emergency response planning. Each department is required to have their own building emergency action plan that provides oversight and guidance during any emergency situation, including fall incidents. It's crucial for all employees to be familiar with their building's emergency action plan and actively participate in any training or drills. This level of preparedness ensures a swift and effective response in the event of a fall, while also minimizing potential injuries and facilitating prompt rescue operations. So as we're coming to the end of this training, let's spend the last part of this training going over all of the key points from each chapter that you need to remember. Chapter 9, key points and final thoughts. Throughout this training, we have covered a lot of topics, and it's important that we don't just treat this as a checklist, as fall protection safety is about protecting lives, including your own. Falls are the leading cause of death in industry, and all of them have been preventable. That's just not a statistic. It's truth, backed by real-world stories, hard-earned lessons, and unfortunately, far too many events. So let's reflect on each chapter and what we've learned. In Chapter 2, we learned that falls are the #1 cause of fatalities in industry. Year after year, they top OSHA's Final Four. These aren't extreme once-in-a-lifetime accidents. They happen during normal tasks like working on roofs, climbing ladders, or even accessing scaffolds. The numbers are rising. That's why this matters. In Chapter 3, we broke down what fall hazards actually look like, whether they're unprotected edges, floor holes, unstable ladders, or even rooftop work. We've reminded ourselves that a fall from just 4 feet can be deadly. We also learned that recognizing these hazards before they turn into incidents is one of the most powerful things that you can do. Chapter 4 introduced the hierarchy of fall protection. It showed us that not all controls are created equal. That's because elimination is the most effective way to get rid of the hazard entirely. But when we can, we move down the ladder through passive systems, restraints, arrests, and finally administrative controls. So remember, always aim to use the safest, most effective option available. Start with elimination and work your way down when each is not feasible. Chapter 5 gave us a deep dive into fall protection systems, guardrails, harnesses, anchors, and lanyards. We talked about how personal fall arrest systems should be your last resort, not your first. And we stressed that the equipment is only as good as how you use it. Proper fit, daily inspections, and real anchorage points. These are the non-negotiables. In Chapter 6, we took a close look at ladders, scaffolds, and aerial lifts. These are tools that we use every day, but often take for granted. We learned about the 4-to-1 ladder rule and why you must be tied off in boom lifts. Common tools don't mean common sense. Misuse can still occur. In Chapter 7, we emphasize that what happens after a fall matters too. Rescue plans aren't optional. Suspension trauma can kick in within minutes. A proper plan, practiced, equipped, and understood can mean the difference between life and death. At the University of Kentucky, these plans are required and tailored to each building. And in Chapter 8, we reinforce the importance of training and compliance. Yes, OSHA requires it, but most importantly, your life depends on it. Training isn't a box to check. It's how you build habits, identify risks, and protect you and your coworkers. UK's training programs and building emergency action plans are designed with that goal in mind. At UK, we believe safety is everybody's responsibility. By following the fall protection program, completing the required training, and participating in all building emergency action plan drills, each employee contributes to a safer campus. So here's the truth about fall protection. Every person on your team, including you, has the power to prevent a fall. You don't need a badge or title. You just need the courage to stop any unsafe work, the discipline to use your equipment correctly, and the humility to ask if you're unsure about a task. You owe it to your coworkers, to yourself, and especially to your family. So take the things that you've learned today and put them into action. Remember, do your equipment checks. Speak up if something looks wrong, and follow the processes and procedures, even when no one's looking. If you ever doubt whether inspecting your harness, ensuring a proper anchor point, or not using a ladder correctly is worth the hassle, remember, the fall doesn't care how experienced you are, and the ground doesn't give second chances. So remember, stay safe out there, look out for your coworkers, and go Cats.